In the afternoon, we usually start our class at 2 o'clock. The first class will during the time slots 2 o'clock to 2 o'clock 45, and the second class will be 2 o'clock 2 and 55 to 3 o'clock to 40. Okay, that means the first class is to 45. Second class will be 55 to 3 o'clock 40. Okay, this is the second class. Okay. Okay, let's start. In previous class, we have learned that how to use the gradient method to update or to solve the optimal solution. We just use this. We use the first order derivative of L to update the P and lambda. That means P1, P2, Pn lambda equals the initial value of the value of previous iteration minus alpha. This is a constant. Multiply the first order derivative of L. What's the first order derivative of L? Is just this. This is for the first order derivative for P1. This for P1. This for Pn. So P1, P2 until Pn. The last row. The last row is for lambda. Okay. So the first is L over P1, L over P2, L over Pn. The last row is L over lambda. Okay. This is the first order derivative of L. Okay. For this example, we give the initial value for P1, P2, P3 like this, 300, 200, 300, and we also give the value of lambda just as the average value of the incremental cost of these three generators, just like this. This is for df1, dp1. This is for df2, dp2. This is for df3, dp3. Make a summation here, summation, and divided by 3. So this is the average. Okay, we got the initial value of lambda. Sorry. So that means we have the P1 0, P2 0, Pn 0, and lambda. So we have calculated this part. The next, we should calculate this. Okay, how to calculate this? We just use this, the expression to calculate this. If we have this, and we give the constant value of this, we will update P1 until Pn and lambda. Okay. So let's see how to use this program or to use the MATLAB to code this or to solve this problem. First, we just input the coefficient of these three generators. This is for generator 1. The first row is for generator 1. Second row for generator 2. Third row, generator 2, 3. You'll see the coefficient 1623, 0.004686. You'll see this is the first for generator 1, generator 2, generator 3. You know this is the constant, this is the coefficient for the linear term, this is the coefficient for the square term. You'll see constant, linear term, square term. Okay, you should keep in. When you make program, you should keep in mind what's the meaning of each coefficient. So this is the constant term. This is the linear coefficient of linear term. This is the coefficient for the square term. Okay. We also give the initial value of P1, P2, P3, 300, 200, 300. You see, 300, 200, 300. Okay. This is the initial value. That means P power is the initial value. Alpha, we just guess as 1. Here, we lambda set, we just use alpha as 10% or just 1. Okay. So we just set the alpha 1. And the total load is 800. This is we have to supply a total load of 800. Okay. So the next row n equals length gen data. Gen data is just a matrix, you see. This is the matrix. So this means, so this after this command execute, n will equals 3 because you have 3 rows. So n equals length. This matrix will make n equals 3. Okay. Next, we just initial the lambda at 0. Okay. So let's analyze what's the meaning of this loop. For I from 1 to n, here you know n equals 3. So that means I equals I from 1 to 3. Okay. Here, just 3. Yeah. So for I from 1 to 3, that means for I equals 1, will be lambda 0 equals lambda 0. Lambda 0, what's lambda 0? Just 0. So that means 0 plus gen data when I equals 1. This gen data will 1, 2. You see, what's the 1, 2? Means the first row, second column. First row, second column. So the number will be this. Okay. The number will be this. This number plus 2 multiply 1, 3 will be this element. So this will be 23 something plus 2 multiply this coefficient multiply power I. When I equals 1, power I. Power I means the first element of this vector. So that means this. So it means this value. Yeah. So for I equals 1 will be 0 plus 23 plus multiply 300. So what's this? You see, this is just df1, dp1. Yes, because you have this expression plus 2 multiply this coefficient multiply p1. The 300 is p1. So this is just df1, dp1. So for I equals 1 is this. Similarly, if you increase I to 2, this will be lambda 0. This lambda 0 is already updated here. So that means df1 plus for I equals 2. This will generate the data to 2. That means the second row and the second column. So this number plus 2 multiply 2, 3. Second row, 3 column. So this to multiply this number multiply power 2. The second element of power. So this. So from I from 1 to 2. This you have already calculated this. P2. And further you increase I to 3, you will got this. Okay. EP3. Okay. Please keep attention to this here. Okay. Because lambda 0 equals lambda 0 plus this. Okay. So for next step, lambda 0 equals lambda 0 over 3. You will got the average value of lambda. So for this part, you just calculate this. df1 plus df2 over dp2 plus df3 dp3 plus and over 3. You will got the initial value of lambda. Okay. So until this step, you got the lambda 0, and you also p1 0, p2 0, and p3 0. Okay, this is p1 0, p2 0, p3 0. So until this step, you have prepared the initial value of p and the lambda. Okay, so let's continue. Next, we define or we give another variable x0 and we connect this value of this variable. So x0 equals power means x0 also 300, 200, 300. And the next x0 equals this because there are 3 elements. So for this step, x0 is also 3 elements, means that x0 also equals 300, 200, and 300. Okay, for this step, it's just 3 elements. Next, x0 n plus 1. What's n? N equals 3. So that means x0 4. That means the fourth element of x0 equals lambda 0. What's lambda 0? You have calculated here. Okay, you have calculated here. So this is lambda 0 here. Okay, so for x0, this is p1, p2, p3, and lambda 0. Okay. Okay, you see, so we have already prepared this part. P10, P20, Pn0, and lambda 0. Okay, the next we should calculate the first order derivative of L. Let me show how to calculate this. Okay, for kk from 1 to 10, actually this kk just iteration means iterations. That means the program will stop and at kk equals 10. You see here. Okay, so this DISP kk just means display. It doesn't have physical operation. So next linear gradient, that means the gradient of the element of gradient equals 0, and gradient equals blanket. Next, we have a new value p10 equals 0 and cost equals 0. This is just the initial value for these variables. Okay, next, this is the k part. Okay, for k from 1 to n, I have already mentioned n equals 3. So this sentence is equivalent like this. I from 1 to 3. Okay, for I equals 1, you will get gradient 1. Okay, equals 1, 1, 1. Okay, this n is 3. So, okay, so x0 3 plus 1. So what's the meaning of this? Generator 1, 2 is this number, and generator 1, 3 is this number. So this part is df1, dp1, yes. And minus, what's this? You see here, lambda. x0, 4, the fourth element is lambda. Okay. So for I equals 1, you have already calculated this part. Yes. And for this line, pgn, because here is 0, so that means pgn equals 0 plus x01. x01, what's x01? It's just p1. You see here, x0, the first is p1, 0. So pgn for I equals 1, the pgn just p1, 0. Okay, the cost is 0. So here is 0. Plus generator 1, this number, plus generator 1, 2 multiply x01, 1. Okay, so this part is just for full cost of generator 1. This is for I equals 1. And after you increase I to 2, you will calculate gradient 2 equals this. Generator 2 plus 2 multiply generator 3 multiply x02. What's x02? Is p2, 0. And minus lambda. So for I equal 2, you will calculate df2 dp2 minus lambda. Similarly, for I equals 3, you will calculate df3 dp3 minus lambda. Okay. And for this line, for I from 1 to 3, you will calculate the summation P1 plus P2 plus P3. Okay. That means after execute this loop, their PGN will be sigma P1 plus P2 plus P3. And also after the loop execution, the cost will be f plus 1, f plus 2, f plus 3. Okay. After finish this loop. Okay. So for this loop, what have we done? What have we done for this loop? We have calculated the df1 over dp1 minus lambda, and also this, and also this. We have also calculated the total summation of the generations. We also calculate the total fuel cost. Okay. So next, gradient n plus 1. N equals 3. So that means gradient 4. Okay. Because 3 plus 1 equals 4. So here we have calculated gradient 1, 2, 3. Gradient 1 is here. Gradient 2, gradient 3. So gradient 4, the total load minus total generation, because we have calculated here. This is the total generation. Okay, I from 1 to 3. So this is the total load minus total generation. Okay. So the fourth element is the load minus total generation. Okay. Sorry. Let's see. This is for df. This is for the first order derivative of L over P1, P2 until Pn. The last element is the total load minus total generation. So that means until here we have calculated this, the first order derivative of L. Okay, dp1 df1 for generator n. This is for the L over lambda. So we have calculated this. So the next step, we just display. This is just display. X0 is display. Okay. Next, x1 equals x0 minus alpha multiply delta LL. What's delta LL? You see. This equals initial value minus alpha multiply delta L. What's delta L? Is this alpha 0 minus gradient multiply alpha. What's gradient? Because gradient 1 is this, gradient 2, gradient 3, and gradient 4 is this. So we will update the new value of x. For the next, we should update x0 by x1 and return here. Okay. That means for the kk equals 2, we will use the update x1 as x0 to repeat this loop. Okay. So I have shown you how to use the MATLAB to code this program here. That means how to apply the idea in the program. First, we have calculated the initial value of P1 0, P2 0, Pn 0, lambda 0. We have also calculated this part, means the first order derivative of L. Okay. First order derivative of L. And after this, we have prepared this, and delta L, we will calculate P1, P2, Pn, and lambda. We will update the value. After we update the value, we will use this value as the initial one to continue this loop. That means we use this to update this. And we will also update and first order derivative of L and continue to update P1, P2, Pn, and lambda. Okay, we will repeat this loop. And the maximum iteration is 10. Okay, that means We will repeat this loop for 10 iterations. Okay, for 10 iterations, and we will find the solution. Okay, let me see. Okay, this is the program. This is the result of the program. First, we give an initial value for P1, P2, P3, and also we calculate the average value of lambda based on this sentence. Based on this sentence, we will got the value here over 3. So this is average value for lambda. This is the first iteration. After this, we will update the P1, P2, Pn, and lambda based on this initial value minus alpha multiply the first order derivative of L. We will got the new P1, P2, Pn, and lambda. Okay. And based on this updated value, we will continue for the third iterations. And here we have the maximum iteration 1 to 10. So you'll see we have the max iterations as 10. And the last is this. Okay. Not that though we have paid much effort. The iteration procedures is not converged. Do you have any idea? Okay. This is because that there dependence between the 3 generators, and that means there's some redundant relationship between these 3 generators. To solve this problem, we should use P1 and P2 to express P3. That means we should delete some redundant relationship between P1, P2, and P3. Okay, so realize that one of the generator is always a dependent variable and remove it from formula because we have to make the power generation and power demand balance. So there is always a relationship between P1, P2, and P3. That means P1 plus P2 plus P3 equals 800. So there is always a dependent relationship between P1 and P2 and P3. Here, how to solve the convergence issues? We just use P1 and P2 to express P3 based on power demand and generation balance equations. So, for example, we pick up 3. That means we use P1 and P2 to express P3. Then we will got P3 equals 800 minus P1 minus P2. Then based on this, we will got the total cost as this. The P1 and P2 is the same as the previous, and P3, this is P3. So we will got F3 800 minus P1 minus P2. This is the F3. So this function stands by itself as a function of 2 variables with low load generation balance constraint because we have already considered the load generation balance constraint here. Yeah. So there's no further constraint to consider this. Okay. So after this transformation, we have a formula like this. We have to minimize this function without any constraint, without any equality constraint. You see. So we continue to use the gradient method. How to use the gradient method? We also very similar. We have to calculate the first order derivative of the function. Also, we have to prepare P1, P2. You see, P1, P2 equals P1, P2 equals P1 0, P2 0 minus alpha, the first order derivative of C. So we have to prepare this and this. Okay. What's the expression for the first order derivative of C? Based on the expression of C, you can calculate the first order derivative of dc dp1 dc dp2. Okay, this is the dc dp2. This part is the first order derivative of dc dp1. You say the first order derivative and plus f3 800 minus p1 p2. You have calculated the first order derivative of p1. Here is the minus, so this is the minus. Okay, minus f3 dp1. So the first order derivative of C over dp1 over p1 is this. The first order derivative of C over p2 is this. Okay, so we have calculated the first order derivative of C. We give a constant scalar for this. We give an initial value for p1 0 and p2 0, and we can update p1 p2. Okay, so based on this, we can also find that granting goes to 0 means that when this goes to 0, the first order derivative of C equals 0. That means the first order derivative of f1 over p1 equals f3 over p1. And also the f2 over dp2 minus this equals 0 means df2 dp2 equal df3 dp2. Okay. When the increment cost at generator 3 is equal to the that of generator 1 and 2. So let's say how to use this granting method after the transformation. That means after we express generator 3 by generator 1 and generator 2, how to update p1 and p2. Okay. The granted steps are performed in a similar way, just like x0, x1 equals x0 minus first order derivative of C multiply alpha, and x was x. X is p1 and p2, just as said here, right here. Okay. So rework the previous example with the reduced gradient. This the first order derivative of C will be df1 over dp1 minus df3 over dp1. So this is for df1 dp1. Okay, this part is for the this part is for minus df3 over dp3. Oh, sorry, here it should be 3. Here it should be 3. Okay, here it should be 3. And this part is for df2 dp2 minus this is for df3 over dp3. Okay. And we set alpha to another different initial value as 20. And based on this, this part is the same. Okay, this part is the same for the fuel cost coefficients and the initial value of p1, p2, p3. And we choose a different alpha, and the load is 800, and the length, this means n equals 3. Okay, so the x0 means x0 equals, just make the power 1 to n equals 3, so that means 1 to 2. So means that the first two elements from 1 to 2, so x0 equals 300, 200. Okay, and the key also means the maximum iteration. Okay, therefore here is just a loop. Okay, for the maximum iteration, like display near is doesn't matter. Gradient equals 0. Pn Pload means the 800. Okay. So for I from 1 to n minus 1 means 2. So Pn means that Pn pload minus x0, 1. When I equals 1, this will be x0, 1. What's x0, 1? Is P1. So that means pload minus P1. When I increase to 2, this will minus P2. So Pn will be this. What's this? Will be P3. Okay. So for this loop is for this loop is just calculate P3. Okay. Next, cost. The cost n because here n equals 3, so generator 3. Okay, so this is going to calculate what? Calculate F3. Okay, so it calculates fuel cost of third generator. Next, what's this loop? For I from 1 to 2, gradient 1, 1, 1, 1. And this is 3. This is 3. Okay, so that means gen data 1, 2 plus 2 multiply gen data 1, 3. This means this number plus 2 multiply this, multiply P1. Okay, this generator 1. Minus gen data 3, 2 here. Minus 2 multiply gen data 3, 3. Just this number. Okay, multiply Pn. Pn, what's Pn? Pn you have calculated here is just 3. Okay, so this part is df1 dp1 minus df3 by dp3. Okay, and when I equal 2, you will calculate df2 dp2 minus df3 dp3. Okay, so for cost here you have calculated f3 here. Okay, so for I equals 1, you will calculate 1, 1, 1, 1, 1, 1. So for I equals 1, you will calculate f1. f1 plus cost. What's cost here? Is f3. So means f3 plus f1. When I increase 2, you will plus 2, f2. So after this loop, you have calculated this, and you have also calculated total fuel cost I from 1 to 3. Okay, so next is update this, and next is x1, x0. What's x0? You see here, p1, p2, p1, p2. Okay, minus gradient. What's gradient? You see here, it's gradient. Okay, multiply alpha. What's alpha? To 20. So you update x. Next, you use x1 and x0 to repeat this loop. Okay. How much iteration for this? The maximum iteration is 10. So based on this, we will got the new solutions. You will find that for P1, P2, you will get this, and you will get the total generation at 800, and the total cost is this. Even though after 10 iterations, the iterator procedure converged to the optimal solution, and the final solution is 23,192. Okay, you say the procedures converged to the optimal solution. Actually, based on this, you found that almost at the 6, the total fuel cost is not changed. So that means that we don't need to spend as much as 10 iterations to get an optimal solution. We only cost 6 iterations can get the optimal solution. You see, that means the procedure converges via 6 iterations. Okay. Okay, there are 5 sliders. So let's continue. In previous, we have there's the lambda iteration method and also the gradient method. The next method is better than the gradient and lambda iteration method. We call it as the Newton method. With Newton methods, the solution procedure can be taken one step further. Observe that the aim is to always drive the gradient to 0. Since this is just a vector function, Newton's method finds the correction that exactly drives the gradient to 0. Okay, let me show you a very simple mathematical problems. For example, like this, we want to find a function gx equals 0. You want to find the root of this equation. How to find this? If we use the Taylor's series, just using the linear term, we will call this gx plus the first order derivative of gx multiply delta x equals. That means you find this equals 0, just equivalent to find this to equal gx plus the first order derivative of x multiply delta x equals 0. So based on this, we will calculate delta x. How do you calculate delta x? Okay, based on this, we will have this. Delta x equals minus gx over the first order derivative of gx. Okay. So if you have the this is just a single function. If you have a vector, this vector includes multiple functions. Then the first order derivative of this vector will become a matrix. That means the first row will be g1 over x over x1, x2 until g1 over xn. The second row will be g2 over x1 until xg2 over xn. Okay. The last row will be gn over x1 until xgn over xn. Okay. This is if you have a vector gx, you will get the first order derivative in terms of a matrix. Okay. So based on this, we can calculate delta x like this. Delta x equals minus first order derivative, this inverse. The inverse is very similar like this, over first order derivative. This is just the inverse. Okay. Inverse gx. Okay, so that means if you got a initial value x, and you can also get the first order derivative of gx, and based on this you can update x. Okay. How to collect this with the physical meaning? Okay, let me show you. Let me draw a curve for you. Yeah, if this is a curve, okay. This is x. You have a curve like this. This is gx. Okay, your problem is you want to find the root. Gx equals 0. You want to find the root. So how to find this root? First, you don't know where the real root is. First, you get the point x. Okay, and for this point, you can calculate the first order derivative of gx. The first order derivative is actually the slope for this point. Okay, slope for this point. Okay, so that means gx first order derivative equals gx minus 0 over x minus if I set this as 1, okay, it will be x minus x1. If we, okay, so we will have this x minus x1 equals gx over first order derivative of gx. Then we will get the new value. Okay, x1 equals x minus gx over gx first order derivative. So that means based on this, you will find a new point or new solution of x1. And after this, you use this to use this point here, and you draw a new line. You will call x2 based on this. That means x2 equals x1 minus gx1 over first order derivative of x1. Okay, you will got x2. And repeat this procedure, you will got the further solution xn. Okay, this is the physical meaning of this. Okay, so based on this, we have know that if you calculate the root of gx equals 0, you can use this to update. Now, for our economic dispatch, what's the optimal solution for this? We have know this. The first order derivative. The first order derivative of, let me see. The first order derivative of L, the first order derivative of, the first order derivative of L, Pi equals 0. And also, first order derivative of lambda equals 0. Okay. So, if we see this part as gx, what's this? This just delta L. Okay, the first order derivative of L, first order derivative of L. So that means we have to find the solution of gx equals 0. That means first order derivative of L equals 0. Okay, so that means we have to find the first order derivative of L equals 0. So what's the first order derivative of gx? That means the first order derivative of this. Okay, of this. Okay, this is the first order derivative. Okay, so delta x equals what's this? This is just gx. You see? Okay, this is just gx. Okay, so it's very similar form gx over first order derivative of gx. So delta L over first order derivative of L over x. Okay, so delta x. So to use Newton's method, we have to calculate the first order derivative of this part. First order derivative of this part. Okay. That means we have calculated the first order derivative of this. The first order derivative of delta Lx, we will get this L over x1, L over x2, until L over lambda. This is the first order derivative. Okay. And after this, we have calculated the x1, x2, and xn. So we will got this L over x1, x2, x1, x2. That means, let's see here. Okay. What's this? Will be L x1, L x2 L xn L x lambda. This is delta L. Okay. What's delta L be over x? This will be a matrix. First, x1, x1, xl, x1, x2. Okay. L, x1, x3 until x1, xn. The last will be x1 lambda. Okay. This is the first row. The second row is the same, will be x2, x1, x2, x2. Okay. So the second you only have to change the first term. Okay. So we will got very similar like this. Okay. So for the second term, for the last row we will got this. Okay. This is this part. Based on this, we will find that it's very simple, because for the quadratic terms, you say L over P1, you calculate the second order. If you calculate the second order, there will only be left the coefficient of the quadratic term. You see here. Okay. For this term, that means you have to calculate P, the order over P and lambda. You will got the constant minus 1. Okay. You will got the constant minus 1. That means L over lambda over P, you will got minus 1. Okay. This is the last row. For this row, similarly, you L over lambda over P. So this will minus 1, minus 1. Okay. So for this matrix, if you have this term, this will be the dialog element and the last row and last column. Okay. So for this matrix, you will got expression like this. This you only have the dialog element, also the last row and the last column non-zero element. Okay. So solve the previous dispatch examples using the Newton's method. We will got this. If you calculate H, and you also calculate delta L, you can update X. Okay. That means delta X. Okay. Delta X equals minus H inverse multiply delta L. Okay. Okay, I will finish this part in 2 minutes. Okay, just wait and just pay some patience. So we have this part H. Okay, let's control see how to run the program. Also this part. Oh, sorry. This part is for your coefficients. This is first row P1, P2, P3. And this is the initial value of P0 and this total load. And this means n equals 3. Okay. H here means just 4 multiply 4 matrix. Okay. And for I from 1 to n, that means from 1 to 3. H1, 1 will be generated 1, 3. What's 1, 3? You see this one. Let us see. What's the first order derivative of full cost of generator 1 to P1? If you have this, let me see. If you have this expression, what's the second order derivative? Of course, you will only left to multiply this coefficient. after you calculate the second order derivative, yes, to multiply this will be f1 dp1. You calculate the second order, so to multiply this. Okay. You will first order, second order, you will only left this to multiply this coefficient. Okay. So that means this part calculates okay. This means you have calculated this term. Okay. Similarly, you calculate this term. Okay. So for I equal 2, you will calculate this part. For I equals 3, you will calculate this. Okay. Next, hi I equals 1, this will be 4. Okay. h14 minus 1 means that the first row of fourth element equals minus 1. They have filled this element. Okay. When I equal 2, you will fill this element. I equals 3 will fill this element. You see, 2, 4, 3, 4 equals minus 1. Okay. So you have filled this 3 element. You also, for 1, the fourth row, first column, you will fill this. After, and then you fill this. Okay. That means I equals 1, you fill 1, 4, and for 1. Means when I equals 1, you fill this, and this part. When I equals 2, you fill this part and this part. Okay. For I equals 3, you fill this part and this part. Okay. So after this, you have already calculate h. Yes, h. So next, we give the initial value x0, e0 for 1. This means we have a matrix. We have vector 0, 0, 0, 0. The vector has 4 elements. So the next x0, 1, 3. We just use the power. That means after this, we have 300, 200, 300, and 0. This is x0. Okay. Like display and gradient 0 for 1 and gradient for 1 payload means the gradient the last is payload 0, 0, 0 is also a 4 element. So next, the gradient 1, 1 equals generator 1, 2. So this calculates the this calculates df1 dp1 minus what's this? You see x0 4. This is x04. It's actually lambda. Okay. So for I from 1 to 3, you actually calculate delta L. Okay, for this part. So for next, for next, you will use this. dx. Okay, let's see. You have used this h. This is h minus inverse delta L. So this part is inverse. Multiply delta L. Okay, so you got the delta x. After you got delta x, you will calculate x1 equals x0 minus delta x. Okay, you will got the updated value of x1. For this, you will return back to here, and iterative for 10 iterations, you will got the solution. Okay. So based on this, you will got the solution like 1, 4, 2, 3 iterations, you will got the solution like that. So for this Newton method, you say you only have to cost 4 iterations and you will got the solution. For previous gradient-based method, you have to cost 6 iterations. So that means the Newton method can converge faster than gradient method. Okay. So compare with the previous example, the Newton methods can converge fast. Okay. That's all for today's class. If you have any questions, you can give me message. Okay. So at what time? No. Some of us have had issues logging in. I initially joined directly via link. I was aware. I'll say I was in attendance. I barely got sent from friends. Thank you for. Oh, okay. I understand you. You have already joined our class. So please inform the guys who are not registered in the class. Please join the class as soon as possible, because I will send some homework in the next few class. In next few class, and you guys are divided into several groups, and each group will give us a report and also give us a presentation. This presentation and report will be scored, and your final score will be make up of these 2 parts. First, presentation, and second, it's report. So please register this class by the Pi link as soon as possible. Thank you all. That's all. Thank you. Do you have any question? Can we form our? Yes, of course. I will just give you some topics. And also I will provide you the materials for your presentation. You just learn the material and show what you have learned, just as I teach in this class. I mean that you learn from me and to teach other students, to teach your friends, and just I teach you. And you will get the score for the presentation part. The material I will provide you. You just learn the materials, okay? And also for the final report, you will make some program based on your presentation and write the report in groups. Did you assign group members? No, I will just give the presentation materials and the project titles. You can make groups yourselves. I mean that you can invite several of your friends to make a group. It's okay. Okay.
Laushi?
Yeah. Please.
So how many students can be in one group?
Maybe at present I see there are more than 40 students in this class. So I guess there will be 5 or 6 students in a group. Okay, 5 or 6. Okay. Yeah, 6 members. Okay.
Report. Excuse me, Laushi?
Yeah, please.
Can we make a report with less than 5 members?
Yeah, you for the presentation and for the report, you can form the same program. For example, you invite 5 guys into a group. You do a presentation for economic dispatch, and finally you can also submit a project or report for economic dispatch. I mean that for the presentation and for the project, you can choose the same topic. That's easier for you. Okay.
Okay.
Topic list, please. Okay. I will show you the presentation material and topic list in this weekend. Just wait 2 or 3 days, okay? Because I'm not sure everyone has registered in this class. I just wait them for more 3 days later. Okay. Okay. So if you don't have any question, let's end our class today. Thank you all. Thank you for attending this. Bye.